Hi, I'm Somneswaran Nadraja and my matrix number is 279803. Now I'll start the presentation with identify what the crash happened. The accident occurred for a variety of causes. Included in this group are the train speed and the design of the concrete structure of the curve. Firstly, the train speed. Data on automobile accidents demonstrate again and again that driving too quickly and irresponsibly may result in catastrophic injuries and even fatalities. Trains are no exception. In recent years, there have been a number of railway accidents that have shown that the greater the train speed, the more severe the potential outcome of a collision are, and that more likely it is to derail. The second one is the design of the concrete structure of the curve. Construction must follow rules and specifications to ensure safety and strength. According to code, project materials should be adequate. Materials that satisfy code and are correctly chosen will meet soil conditions. Design calculation must be done carefully to avoid unwanted occurrence and expensive structural detailing is the main cause of fractures and collapse. Use proper, steady, and efficient structural organization. The building should be built to avoid water from battering it. Avoid cracks by approximately placing movement joints. Follow reinforced concrete element code requirements. For instance, maximum and minimum reinforcement ratio, steel bar, spacing to limit cracks, lap length, and anchorages. Poor building procedures, poor craftsmanship, and quality materials in adequate supervision may diminish concrete structures' performance and lead to failure. This train was operating on rails that were not meant for the faster class of high-speed trains since such trains were already running on them. The interference being made is that the rail must have in some way been responsible for the disaster. Cheaper tracks do vibrate more and wear out more quickly than higher grade ones. Now, the second part, identify why there were many casualties. The collapse of the bridge had a significant influence on the destruction of the carriages, which in turn had a negative effect on the whole situation. According to the findings of this investigation, the architecture of the area around the bank, which included the sharp edges of the water clutch that ran behind the railroad track, was responsible for some of the carriages becoming open like cans of soup. The interior environment of the carriage. In addition, injuries might be caused by unsecured baggage and interior that has been left too loose. Because of the train that did not have baggage hatches that could be closed, like those seen in aircraft, it was possible for bags to behave as missiles and cause injury to passengers. During the crash happened, the passengers were most likely flung against a variety of buildings as well as against each other since the train carriage did not have seatbelts in.
Hi, I'm Pulina Shiniravan and matric number 279666. I will continue the presentation with recommendation. According to the case studies, we'll look at the injuries, both fatal and non-fatal, that were sustained during the crash, perhaps, of the high-velocity train disaster. A high-velocity train is mostly like the cause of mass casualties with significant number of deaths and also critical casualties. Positive Train Control (PTC) is a GPS system that's works together with radar and track sensor that allow computer to remotely control a train if an operator isn't handling the locomotive correctly. The main concept behind Positive Train Control is to avoid the collision and prevent the speed derailment. Three distinct devices communicate with one another over PTC network is systematic office dispatch, onboard computer system, and wayside ping units. Moreover, before a train departs on the trips, the onboard computer system downloads the information on the roads from centralized office dispatch. These informations include posted speed limits on the roads along with any potential hazards. As the train travels is constant contact with dispatchers via onboard computers and the trackside ping units. These units may also built into the track itself. The ping units are connected to both dispatchers and their train's onboard computer via a radio network, so both dispatchers and the trains are always aware of speeds and also the location. Other than that, if the train is moving too fast for an area, the onboard computer sends a warning to the engineer. In the event of an emergency, the PTC systems can override the actions of the engineer, slow or stop the trains by remotely applying the braking system. Among the crashes that can be prevented with Positive Train Control, PVC is crashes linked to exclusive speeds, train-into-train crashes. That's all from me. Thank you for listening.
Good day, doctor and my fellow friends. My name is Chai Jijie and my metric number is 279606. Today I'm going to talk about DAS. So DAS is a system that has been used in many countries and it has several projects on DAS that can help to reduce the train crashes and facility. So the first project is RouteLink. RouteLink is designed to improve the efficiency of communication between the train drivers and traffic control. improve railway traffic, energy consumption, and passenger comfortability. So routing is installed to deplete the surrounding traffic status, emphasizing upcoming track portion, shows their status such as whether the route is reserved for the driver's train or blocked by another train. So in addition, any train delays in the depleted regions are indicated. So routing benefit energy conservation and communication effectiveness between the train drivers and traffic controllers, likely due to the improved information provided to the train drivers. So this can reduce the train crashes and facility due to their communication between train drivers, improve traffic control, and transparent data, which will lead to decreased cases like the train collisions. The second project is FARE. FARE is designed to offer the driving recommendation computer based on a continually updated traffic control schedule. So for instance, FARE is being used in Switzerland because 10-second variation from this timetable might create crashes with another trains. So FARE focuses on preventing such deviation. It indicates the most significant delays that may be recovered within a particular window and provides the pertinent advice. Symbol provide instructions for rising, decreasing, or maintaining the current speed. So FARE is connected to the real-time data that will provide a solid basic for speeding decisions, and it will also shows the current planning, which will cause the driver to know whether what is going on regarding to the traffic condition. Last but not least is the CATO. So it incorporates information on the real-time data regarding infrastructure, speed limits, and traffic. So the purpose of CATO is to make improvement based on the energy consumption. And it also gives the train operators their flexibility to operate to their drive according to the condition and timetable that have been predetermined. It is the first DAS to interact with STEG, which will use the cutting-edge railway traffic management. So a speed curve, the most recent speed suggestions and information on goals point are all shown by the CATO. So the destination are restricted by traffic management, identifying locations that must be traveled through in a certain amount of time to avoid interfacing with the traffic. That's all from me. Thank you.
A very good day to Dr. Rahimi binti Abidin. I'm Law Min Ching with the metric number 279918. Another recommendation which can be considered is Train Collision Avoidance System, TCAS. This system is defined as an independent railway traffic monitoring and control system, which may give protection for the rails to prevent signal passing at danger, SPAD cases, excessive speed as well as collisions, in case operations are unable to control the emergency situations. Based on its function, TCAS is equipped with sensor data in order to detect other rails and any obstacles on the rail tracks like moving vehicles and pedestrians. Besides, the system has multi-level driver assistance, warning system, and interface to the emergency braking system. In addition, it can identify the rail's location via distance traversed from radio frequency identification (RFID) identifiers which have been set on track, as well as transfer the relevant signaling information from several units like station interlocking. In terms of benefits, the first benefit is to strengthen the safety of train workers as well as the passengers. This system is used to hinder head-on, rear-end, and side-on collisions, as well as assist the improvement of trackside maintenance, labor safety. Secondly, it gets to enhance rail network usage and volume. It means that when there is lesser infrastructure and rail cars are having damages, more cargoes are able to be shipped on existing lines. Thirdly, it develops a better on-time operational performance. TCAS provides little downtime for repairs, and its unscheduled maintenance helps to enhance railway fleet availability. Last but not least, this system is capable of upgrading high-speed rail speed monitoring and control. TCAS is being predictive and equipped with automated alerts, which can assist the train drivers to react quicker to any hazardous circumstances and carry on with positive train control. That's all from our group. Thank you.